Teleportation is basically transfer of a random quantum state which is prepared at a certain station to a station which is far away without just sending it through optical fiber itself. So assume we have two stations. First one is the Alice, second one is Bob. Initially, there is a entangled EPR pair which is established between Alice and Bob. So there is already an entanglement between Alice qubit A2 to Bob qubit B. Then there is a quantum state which is prepared on qubit A1 on the Alice end. And the task is to teleport this qubit to Bob's qubit. So we can simply write the equations for this. This is the state of qubit A1 at Alice. And we have the entangled pair A1, A2, and B, which signifies the EPR pair which is shared among Alice and Bob. We can have the simplification, and which looks like this. Then we can substitute the definitions of Bell basis to this, to first of the two qubits. We have equation something like this, which can be reduced to equation like this. Now, this might seem very complicated, but what we are basically doing is simple algebra itself. This equation is although long, but it's very easy. Assume this, there are four parts to this equation. This is essentially, we have basically written the combined wave function or the state vector for the three qubits. And this is essentially a superposition state. So what we now do is Alice on its two qubits takes the measurement. So basically the wave function would collapse. So if Alice take measurement, it would either be the phi plus, phi minus, psi plus, or psi minus, which are the results for the A1 and A2 qubit. Now these results are then communicated to Bob. Now, if we have phi plus state at A1 and A2, the corresponding state, the B qubit would be in alpha 0, beta 1, precisely the initial or the state that we intend to teleport. So in that case, we just basically apply IGET, which basically does nothing. So then we have correctly teleported the initial state to Bob qubit. But if the measurement outcomes provides that A1 and A2 are in psi minus, then there is a difference of a phase. Then we would apply a poly Z gate to correct for that phase. Then essentially we are having the final state of Bob B, which is similar to the initial state. Same thing happens for the other cases as well, where for psi plus, we would apply the X gate. It would give the same state. Then psi minus, we would apply psi X and psi Z. That would give the final state. So this whole process is called Bell state analysis. So what we are doing, we are analyzing what are the outcomes at Alice, and according to those outcomes, certain single gate operations are applied at Bob end to basically get the correct final state at Bob's end. So what we get, we have teleported the initial state from Alice end to Bob's end.